notes for 6.2, and we are going to split this into two different parts. Today we're going to be dealing with no variables, and on day 2 we will be dealing with variables. So we are going to be applying properties of roots with rational exponents. And remember that when you are working with fractions and you are going to add them, you need to have a common denominator. So that's our most important thing before we get started. All right, so our first thing is we're going to simplify 3 to the 1/8 times 3 to the 3/8. Now notice that you have the same bases, so as long as you have the same bases, we're going to take and add the exponents. So we have common denominators, so 3 to the 1/8 plus 3/8 is 4/8. Reducing it to lowest terms is 3 to the 1/2. That's an exponential form, or we could write it as the square root of 3 in radical form. Either answer would be considered correct. Now the next one we're going to do is we are going to simplify 9 to the 3/10 times 9 to the 1/5. Again, we have common bases, the same bases, so we're going to add the exponents. 3/10 plus 1/5, getting a common denominator of 10. We're going to have 9 to the 3/10 plus 2/10 would give you 9 to the 5/10, which is the same as 9 to the 1/2, which in radical form is the square root of 9, which simplifies to 3. Now we're going to take 32 to the 2/3 power, all raised up to the 3/10, and a power to a power, we multiply the exponents. So 32 to the 2/3 times 3/10. Now again, I would go ahead and cancel, which would leave me with 32 multiplying numerator. 1 times 1 is 1. 1 times 5 is 5. So in exponential form, we have 32 to the 1/5. In radical form, we would have the 5th root of 32, which is just 2. Now we're going to do the same thing with 8 to the 1/3, all raised to 2. So we're going to take 8 to the 1/3 times 2 over 1, or get 8 to the 2/3. Writing that in radical form, we would have the 3rd root, or the cubed root, of 8 all to the 2nd power, and the cubed root of 8 is 2, so 2 to the 2nd power is 4. The next thing we're going to do is just above, you can see if we have a times b to the m, we can separate that as a to the m and b to the m. So we're going to do that here. We're going to go 16 to the 1/2 times 25 to the 1/2. If we make those into radical form, we would have the square root of 16 times the square root of 25, which is 4 times 5, or 20. The next one, we're going to do the same thing. We're going to distribute. So we would have 2 times 15, or 2 to the 15 over 1 times 1/5, and 2 to the 15 times 1/3. Now if we go ahead and reduce that, 5 goes into 15 3 times, we would get 2 to the 3rd, same thing here, times 2 to the 5th, and then 2 to the 3 plus 5, because we have the same bases. So we'd get 2 to the 8th, and if you take your calculator and simplify that, you would get 256. When dealing with negative exponents, we want to make them positive. So we're going to take and go 1 over 64 to the positive 1/3. And then we want to just go ahead and change it from exponential to radical form. So 1 over the cubed root of 64, which is 1/4. And then the next one, you'll notice that it's in the denominator. So to make it positive, we move it to the numerator. So we would have 4 to the 3/2. If we change that to radical form, we would go the square root of 4 all raised to the 3/3 power. The square root of 4 is 2. 2 to the 3rd is 8. Now, when we have the quotient power, as long as we have the same bases, we can subtract the exponents. And again, when you subtract fractions, you need a common my smartboard is not denominator. Sorry about that. It's just not quite doing what I'd like it to do. So here we're going to go ahead and we're going to take, and we have the same basis, so we're going to subtract the exponents. 52 to the 5/6 minus 5/4, getting a common denominator of 12, we're going to have 52 to the 10/12 minus 15/12, which would give us, I'm going to extend this page here, 52 to the negative 5/12. Now, I need to make that positive, so I'm going to take 1 over 52 to the positive 5/12. But we never want to have a radical in the denominator. So I need to rationalize that by making it a non-radical, non-exponent in the denominator here. So I'm going to say, what do I need to multiply or 5/12 by in order to get 12/12? Well, that would be 7/12. So I'm going to multiply top and bottom by 5 to the 7/12. Now 5 to the 7/12 over 5 to the 7/12 is just 1. So I've not changed the value. But when I simplify this, I would then get 5 to the 7/12 over 5 to the 12/12, which would just give me 5 to the 7/12 over 5. And that would be my final answer in best form. So on this next problem, again, we have the same bases, so we're going to subtract the exponents. So we would get 4 to the 3/5 minus 4/5, which would be 4 to the negative 1/5. Making that positive, we'd get 1 over 4 to the 1/5. Again, I need to rationalize that. So I would have to multiply by 4 to the 4/5. 4 to the 4/5. And again, I apologize. I do not know why this smartboard is not writing quite as nicely. But you would then end up with 4 to the 4/5 over 4 to the 5/5, which would be 4 to the 4/5 all over 4. And that would be our final answer. I'm going to stop and end, and then I'm going to start a new video for the back part of this.